Okay, so we're just dealing with another exponential today. What in the world? All right, so we dealt with exponential functions last time. We were graphing exponential functions. Today, with this lesson, that is exactly what we're doing again. It's just a special exponential function. So this is y equals base e to the x. Now, don't be mistaken. E is not a variable. E is actually just a number, which if you notice on your calculator, and everybody, you do want to make sure you can use your calculator for this part. So grab your calculator and make sure you can use it correctly. So base e is actually just a number approximately 2.7. It's not 2.7 exactly. There's a bunch of other. Like if you type in your calculator e to the first, you can see what number it is. So what happened was in real world situations, these mathematicians kept seeing this number come up over and over again in real world settings, this 2.7, whatever the decimal is. And so it came up so often that they're like, let's give this a special like symbol. Kind of like how pi is 3.14, you know? It's just a special symbol. So base e to the x is just an exponential function. So if you can recall, exponential functions all have horizontal asymptotes at 0 unless shifted up or down, correct? Our domain for all exponentials is all real numbers, and then our range will be 0 to infinity. The only thing that would change that is a shift up or down. So grabbing your calculator, let's plug in some points like -2, -1, 0, 1, and 2. Everybody help me out because we're wanting to go quick. So type in your calculator e to the -2 and then just shout out the decimal. Somebody else type in e to the -1, shout out the decimal. Let's go quick. 0.13. Okay, cool? I know what e to the 0 is. It's 1. I know if I plug in 1, I'll get about 2.7. I need -1 and 2. You got what? 0.3 is perfect. 2? Perfect. So looking at me grabbing these points, you guys, we're going over -2 up a teeny bit, over -1 up a little bit more, over 0 up 1, over 1 up 2.7, over 2 up 7.3. So there's our exponential function. Super easy stuff. So this is just an exponential e. Since 2.7 is greater than 1, that would make sense that this is exponential growth. Any questions on e? Pretty straightforward. Okay, so let's see if we could, how we would graph this. Okay, we might even not need to go through it completely. We might be able to just do a rough sketch. So if I said to you, graph, you would do what? Can you tell me the steps that we always take for a shifted function? We would do base e to the x. We would start with that. We would make an xy chart, which we just made a second ago, correct? And then we would transform our xy points. Now it says shifted right 2, so that means we would add 2 to our x's, and then it's up 4, so then we would add 4 to our y's. So where would my new horizontal asymptote be? 4, wouldn't it? All right, and then a shift of right 2. So e looks like this. I'm just going to do a rough sketch if you don't mind. So it's just like right over here more so, but it still looks the same. There we go, rough sketch here. Would you guys feel confident, or do you feel like I'm rushing it? Okay, what's our domain for all exponentials? All real numbers, but our range is now 4 to infinity. Okay, good. Okay, just go ahead and tell me what the shifts are here. This is down 3, so that means y, 3. So now we have an asymptote at -3 here, and then this is a reflection over, yep, reflect over the y. Try to figure out how I can get this to, like it gets sharp. Reflect over the y-axis. We really are struggling today with these pens in my early morning. Okay, reflect over the y-axis. So what what does each of these affect? So we had a couple points. Does anybody have them written down right in front of you? By chance? Okay. So we had our -2, -1, 0, 1, 2. So this was 2.7. I don't know. Hold on just a sec, guys. I'm going to pause this. Okay. So I know that if I plug in 0, I got 1. If I plug in 1, I got 2.7. If I plug in 2, I know I got 7.3. I just don't, this was a 0.3 and this was a 0.1. Okay, perfect. So then from here, reflection over the y-axis affects your x's, correct? So we take our x's and times them by -1, and then our y's down 3. So then we would write down our official new xy points. So this is obviously +2, 1, 0, -1, 2. Do you agree? If I times all these by -1. And then we're shifting down 3, so these will just be decimals down 3 units. So I'm just going to draw a rough sketch here. So we're going over 2 units. Do you want me to, let's write these down actually. -3 plus 0.1, wouldn't that be about like -2.9-ish? Remember for graphing, it doesn't need to be perfect. And then -3 plus 0.3, that'd be like -2.7-ish. And then -3 plus 1 is -2. 2.7 minus 3, that'd be about -1.3. And then 7.3 minus 3, 7, 6, 5, 4, so 4.3. So graphing those points. Over 2, down 1, 2.9, we're right by the asymptote. Over 1, down 1, 2.7. Over 0, down 2 units. Over -1, down 1.3. Over this is a -2. Over -2, up 4.3. Up 1, 2, 3, 4.3. And there's our exponential. So the domain is still all real numbers, but our range is -3 to infinity. Okay. Graphing super easy if we take the same steps we've taken all year long. We're not going to be able to do 2 lessons if this is what we're going to do all day. Okay, we won't graph this one, but just tell me the shifts. Left 1, reflect over x. Was there any shift up or down? So there would be a horizontal asymptote at 0. Then a reflection over the x. Normally, it looked like this, didn't it? Our exponential. Reflect over the x would then make it look something kind of like this, wouldn't it? So I'm just doing a rough sketch, and it was left 1, so it'd be like shifted back a little bit. So then our domain's still all real numbers, but our range is -infinity up to 0. Alright, so if I said to evaluate e to the 3, you'd just type it into your calculator. E to the 3rd, you would type it in. And you would put down the decimal. They would tell you on the test what decimal to round to. So no big deal. If I plug in a negative, will it come out negative? No, right? It just flips it over a fraction. It'll just be a decimal close to 0. Okay. Awesome. Okay, now this story problems, guys, in this unit are super straightforward. They've all been plug or chug. So we're not going to get freaked out. So look right here. It says, an infectious disease begins to spread in a small city of a population 10,000. After T days, the number of people who have succumbed to the virus is modeled by this function. Find the number of people infected in 5 days. So what would I do? Plug in a 5 into T, wouldn't I? So you would literally just plug in 5. Now I do want everybody, we had a really hard time in my early morning using these calculators to get the answer correct. So everybody practice right now so you can make sure you can get to the test and type it in correctly. So this is right here, I'm plugging in 5. This is a times 5. So I want everybody to type it in to their calculator real quick. So everybody make sure you can get this, and if not, we've got to figure out how to help you out with your calculator. Okay, awesome. Now, last time we did learn an interest formula. We learned an interest formula when interest is compounding a number of times in a year, a certain number of times. Now, here's a different interest formula for money when we're getting interest that's compounding continuously. Now, compounding means gaining, so we're gaining interest all the time. As you breathe, you're getting interest. Now, it makes it sound a little bit better than it is, and we'll talk about why. because it makes it sound like you're going to be this rich person if you're getting interest all the time. But it doesn't quite work like that, and interest rates usually are pretty low. But even with an interest rate that's high, we'll kind of talk about why it doesn't grow. Once you get to a certain point, it doesn't grow as much as you think. All right, so PERT. You only use PERT, everybody, for interest if you see the keywords compounding continuous. Otherwise, you got to use that other formula I gave you last time. Compounding bi-monthly and compounding yearly, compounding monthly. That was the other formula. Compounding continuous, you'll use PERT. P is the put down amount, E is E, R is the interest rate, and T is the time in the account. Now, just like with the other formula, you don't need to change it, the percent, to be like 1.08. If we're getting 8% interest, you would just do 0.08. You'd plug it right in. So, as you can see, based on the format of that equation, it's exponential. So it says the amount after 3 years of $1,000 is invested at a rate of 12% per year, compounded continuously. Oh, it says find the amount. So you would just plug it in. You'd say, okay, so Y is equal to our put down amount is 1,000. E is E, because we see compound continuously. Our R is 0.12, and then the time in the account is 3. So everybody type it into your calculator and tell me how much money this person gets after 3 years. At this interest rate, gaining interest all the time. These are both in the exponent up here. .32? 93? Oh, 33. Okay, sorry, 33. All right, perfect. So they gained $433.33. So not bad. Better than having your money sitting under a mattress, not gaining interest. Now here's the thing, guys. You might see, like, if I said that they were gaining interest continuously for 3 years versus monthly for 3 years, it's actually not that much difference in money. What you would think, if you're gaining interest monthly versus any given second of any given day, would be a huge difference, but here's why not. So let's look at an exponential function. It looks like this. Now here's our time, and then this is the amount of money, right? How much money you're gaining. So now notice, like in the first few years here, yes, the difference from here up to here is a decent difference. You guys see what I'm saying? But as we go out over time, there's not as big of a difference. You guys see what I'm saying? Like there's not a big of a gap. So the further out we go, it's kind of like the same money. So compounding continuously is going to be dang close to compounding monthly because it's not that big of a difference. It'll be a teeny bit, like a couple bucks, but nothing huge. So that's kind of why. Kind of like topping out almost, you know? All right. So that is the end of that lesson. Like I said, I told you that would be short. So next week will be review and test days only. That'll be good. Okay, let's do 4-3.